Hello everybody, this is Mr. Garcia. I'm making this video to show you how to use Excel to calculate a quadratic and or exponential regression model to fit your data. Okay, because sometimes a linear regression model just is not appropriate. It doesn't fit our data very well, and so we're going to use two other models and see which one of those fits the data better. Okay, either exponential or quadratic. All right, so let's take a look at, I'm going to use this data set right here, years from 1900. Okay, so when you see a 30 there, that means that, this 30 years from 1900, so that would make it 1930. Okay, when you see a 40 here, that would make it 1940, etc., etc. And then on the y-axis here is the number of registered trucks. Okay, and this is the number of registered trucks in the United States. So in 1930, there were 3.7 million registered trucks in the United States. Okay, and these are all in millions here. All right, so the first thing I'm going to do is make a scatter plot. So I'm going to select my data. So I'm going to click on the cell here with a 30 in it and drag it down until all of my data is selected. Then I'm going to come up here to the Insert menu because I want to insert a scatter plot. Okay, so I'm going to Insert, and then I'm going to come here to Charts, and I'm going to choose a scatter plot. Okay, the little drop-down menu, and I'm going to choose the first one. Okay, click that, and there you go. Here's my scatter plot. Make it a little bigger. All right, and so as you can see, a line is probably not going to fit this data very well, okay, because this looks pretty curved to me. So if I were to put a line through here, it's going to miss a lot of these points, isn't it? All right, so this kind of clues me in that I probably want to choose a different regression model for this data. All right, so I'm going to come here to plus and come down here to trend line. Okay, and you can even see there, it always kind of defaults to a linear regression model, and you can see that that doesn't fit it very well, does it? Okay, it misses a lot of the points. All right, so I'm going to come over here to the drop-down menu for trend line, and then we want to come down to more options, and then we get this dialog box. All right, and so the ones that we're going to look at here are the top one, which is exponential. And then the quadratic one, there's no one here that says quadratic, okay, but really a quadratic is a polynomial function. And there's a whole bunch of polynomial functions, okay, and the order tells you what's the highest power on x. Okay, so for a quadratic, right, the highest power of x is an x squared. Okay, so that's 2, right? We could also have a cubic function, and so that would be x cubed, right, or an exponent of 3. So you can, play around with that if you want, but the only ones you're responsible for doing in the book are exponential and quadratic. And so quadratic is a polynomial of order 2. Okay, so I'm going to try that one first. I'm going to click on that. Okay, and then come take a look, and whoa, that looks a lot better, doesn't it? Okay, this model fits my scatter plot a lot better than the linear one did. Okay, and then what number tells you how well your model fits the data? Okay, do you remember that from last week? That was our coefficient of determination. That, in other words, the R squared. So if I come down here, I can click on R squared. Okay, this says display R squared value on chart. So if I click on that, I'm going to get what my R squared is. Okay, and then I can also click on display equation. Okay, and so that right there is the equation of a parabola, right? In general, it's ax squared plus bx plus c. All right, and so watch the class recording for this, which happened on November 1st. And I explain all the math in here, but right now I'm just showing you how to go through the steps of finding the actual equations and curves. Okay, so there's the equation. There's my coefficient of determination, right? So that's 0.9877. So 98.77% of the reason that the number of registered trucks varies is due to this model. Okay. It's because these points are trying to follow the curve, right? But they don't follow it exactly, do they? Okay, this one's a little above, this one's a little above, this one's a little below, this one's a little below, this one's a little below. That one's right on there, right? So you can see that, so 98.77% of the reason that these points vary is because they're trying to follow this model. But there's a little bit left over, right? That's just due to pure randomness as why this point changed. Okay, and then we can just really easily just come up here and click exponential function and see if we can fit it even better. Okay, so this 98.77% is pretty darn close to 100%. Okay, but can we get even closer? Well, let's try it. So if I click on exponential, okay, whoa, look at that r squared. Now we get 99%. So that's even better than 98, right? If I go back to polynomial, that was 98.77, and if I go to exponential, that's 99.32%. So that fits it even better, doesn't it? Okay. And pretty much every point, right, except maybe this one, and the last one is kind of way up there, okay, but every other point is pretty much almost on the line. All right, so if I had to choose a model, to fit this data, it would not be linear, that's for sure. Okay, and polynomial, it did it pretty darn close, but exponential wins the prize, right? So you want to look at your r squared. Whichever one is closer to 100% that's the curve that you want to go with. Okay, so so that's how you find a regression model for a scatter plot that you don't really know what it what it looks like. Okay, so we use Excel to draw the scatter plot, and then we use this format trendline dialog box to see which one of the three, either linear, exponential, or polynomial, which one fits it the best. Okay, hope that was helpful. Thank you.